Welcome to Tammany Tech 101. I'm Grant Black, Director of Technology for St. Tammany Parish Government. Our goal is to ensure that our citizens grow in their digital literacy. Today on Tammany Tech, we talked to Kevin Calulet, Director of St. Tammany Parish Mosquito Abatement and Medical Entomologist. Welcome, Kevin.
Thanks,
Excited
Grant.
to have you here today.
Thank you for having me.
So, medical entomologist, what is that?
Yeah, so we went to school to study all the insects that are medically important. So insects that cause any sort of reaction, that may be allergies, whatnot. So this is fleas and ticks, and of course mosquitoes, and all the way up to the diseases they transmit, the pathogens that they transmit, like malaria, West Nile virus, of course, is the one we're concerned about here. So all of those things that bite and cause medical problems. Yeah.
So is this when you went to school? I mean, you have a PhD. Congratulations, Dr. Calulet.
Yeah, thank you. Yeah.
So was this the end goal when you went to school? Was this where you thought you were going to end up?
You sort of have a meandering path, I think, and you find what fits for you. I think, are you from Louisiana originally?
I'm
yourself?
from Slido.
Okay, great. So I think it's interesting to think about the role that insects play in everybody's life, but
Sure.
Those memories from my childhood are, and arthropods in like crawfish boils and whatnot, that they're just part of our daily life. You remember poking the ant pile kind of
Sure,
thing. You
sure.
probably remember chasing that mosquito truck too. Everybody seems to remember chasing the mosquito truck, right? That's just sort of part of who you are here.
Mm-hmm.
So I grew up hunting and fishing in Louisiana, and spending just so much time outside. And we moved away, but eventually returned to go to LSU. I was really obsessed with infectious diseases at the time, and really learning about virus hunting, that kind of thing.
Mm-hmm.
So then I went to Tulane University for graduate school and finished with a PhD in vector-borne disease there. And then, I've been here for 10 years in St. Tammany, and 10 years at Mosquito Abatement, and 5 years now as the director.
Wow, congratulations.
Yeah.
So you kind of brought up the mosquito trucks and running behind them.
Yeah.
Would you recommend not doing that?
Yeah, you probably want to avoid exposures to pesticides if you don't have to have that exposure, of course.
Sure.
But what's coming out of those spray trucks is all regulated and approved by the EPA, and is approved as safe even as it's coming out of that. You want to limit your exposure, but those are safe insecticides that are out there.
So we see the trucks, very visible. I mean, you guys do a great job.
Sure.
Congratulations. What really is going on more behind the scenes? I mean, there's a lot more to it than the trucks.
Sure, and really the trucks are what you see at night, and that's sort of the tip of the iceberg.
Mm-hmm.
The night activity is really kind of the last resort. That's our last opportunity to kill adult mosquitoes that may have virus in them, essentially. So what happens during the daytime is a whole lot of inspection, trying to understand where the source of those mosquitoes are coming from, and treating those sources with larvicide products to kill the larval mosquitoes, essentially. So a lot of data collection is happening, and that's happening on iPads in the field from our team of mosquito biologists that are out there. They're also out there responding to calls for service. When people are having mosquito problems, you call us, you fill out our web form that goes directly to those mosquito biologists, and we can go and give you service. And generally, we like to do that as promptly as possible because we know people are having problems. So we're generally there within 24 hours or so, and we can bring them service. So there's a lot behind the scenes that happens to make that occur. Those mosquito biologists are also setting traps to understand and monitor those populations. We have 120 trap sites across the parish. Those mosquitoes come back to our lab. Our lab technicians are identifying the species of mosquitoes. You may not be aware, there's over 60 different species of mosquito in this state. There's 3,400 in the world. We need to know which species are a problem at the moment so we can diagnose where they're coming from, essentially.
How many species do we have you seen here recently?
We have about 56, 57 in the parish.
So 56, 57 of the 60.
Yeah.
In
now,
the state.
Generally, there's only about a dozen or so that are a problem at any one point in time. Mm-hmm. But if you can think about it, each of those species has a lot of them have different hosts they like to bite. Some of them only bite birds. Some of them only bite people. Some of them only bite dogs, whatnot. They have different hosts. They have different sources they're coming from. They may be in a flower saucer container in your backyard, or it may be in a ground pool, or it may be in a ditch in the front yard that receives sewage from an on-site wastewater treatment system. So they're all coming from different places. We need to know which species are there. And when they speciate those mosquitoes in the traps, they're also sending them off in vials for virus testing to the state lab as well.
So you brought up wastewater, which is kind of an issue in St. Tammany. I know you're on the wastewater task force.
Sure.
Is that problem getting better, worse, maintaining? Where are we with?
So I think we're maintaining right now, but I think we have some hope in sight for the future to help clean up that particular problem. But the issue is that St. Tammany has more on-site wastewater treatment systems, or people probably know them as septic systems,
Sure.
On-site wastewater treatment than any other parish in the state. We have over 42,000 systems that we estimate here in the parish. That's about 46% of the houses and businesses have these systems. If they're not properly treated and maintained, they're releasing under and partially treated sewage into the roadside drainage ditches. That sewage in the ditch eventually will kill the natural enemies of mosquitoes. It'll kill the fish. Other things can't survive in that polluted environment, and therefore mosquitoes are produced like crazy in that environment because they have no natural predators there. So that's why it's a problem for us, but it's a huge environmental problem on top of that.
Sure. So we have the environmental problem, and we've also got we're basically creating a huge breeding ground for mosquitoes with all these wastewater plants.
Yeah, absolutely.
Septic tanks.
600 miles worth of roadside ditches that we have to treat weekly. And so if you see a white Jeep with our logo on the side with a light bar up top, those are right side drive Jeeps. They're actually treating with a larvicide product in every one of those 600 miles once a week across the parish.
So you said that we have the most septic tanks in the parish. How many other parishes have mosquito abatement?
So there's about a third of the parishes in the state have a mosquito abatement district. Most of the ones of the parishes in the southern, below I-10, I-12, have mosquito abatement just because of the sheer presence of water that we live in. We're overabundance of water, of course, and mosquitoes find that water wherever it may be. And that's why they're such a problem.
So your job's a little unique because we have the water, but also we have all the septic systems. So you've got a little more complexity.
Right. Well, yeah. And if you think about it, we've got 65 square miles of coastal marsh on Lake Pontchartrain. We've got the Pearl River Basin, swamp habitat. These are all different habitats, and they select for all different species. And on top of that, the sewage issue as well. So it's a key problem. Really, how people have structured where the water is and what we do with the water is structuring where the mosquitoes are.
Sure.
So that's the big issue.
And people like living by water, so then that puts people next to mosquitoes.
Yeah, absolutely. So they're a way of life, but that's what we're here for. We're here to manage mosquitoes to minimize the risk of infection for West Nile virus, essentially, as well to manage nuisance mosquitoes to a tolerable level as well.
So this is Tammany Tech. What role does technology play in combating mosquitoes?
Yeah, I think technology is a huge role. I think it's to start off a communications role. I know you and I have talked a lot about mapping. Mapping is another passion of ours. We have a geographic information systems manager on our staff that maps out where these mosquitoes are coming from. We just talked about all those different habitats. We need to know where and when. So there's an automated function that we have to play with, collecting all that data, bringing all that data in and processing it to understand where we're going to send those trucks, where we're going to send the helicopter and the airplane out at night, where those larvicide units need to go on a daily basis. So technology is playing that communications role, and that generally for us happens through the maps itself. We have folks out in the field collecting enterprise GIS data on a map, on an iPad tablet. Continuously, all of that data is coming back to our office, help us make better decisions going forward.
So the trucks, do they have maps in the trucks that they
Yeah,
fly?
absolutely. The trucks, those Jeeps I just mentioned, those larvicide Jeeps, but the night trucks as well. There's a laptop in those trucks, and that's relatively old technology now, GPS, but it's pinging every second that truck is out there. The laptop's telling them where to go to spray in the first place. So that way we're treating the areas that we need to treat, and we're not treating the areas we don't want to treat. We don't want to treat around beehives, for instance, or other sensitive areas. So we're cutting those out of the map, guiding our technicians to where to go. So that's the communication tool, the map. And then it's pinging the GPS locations so that we know exactly where they've been, we know how fast they were traveling, and we know how much chemical was coming out of that spray unit, because the spray units themselves have a flow regulation that's based on the speed. So that way we know we have the precise amount of insecticide If we slowed down and it had the same rate, we would be over applying insecticide. Sure. So it regulates how much insecticide's coming out of the nozzle by the speed of that vehicle.
It's pretty impressive.
Yeah.
So you mentioned bees, huge problem worldwide. We have a kind of a bee crisis. So I mean, you basically are taking the environment into heavy concern as you're spraying.
Yeah, I mean, environment is, so safety is number one for our staff and for our residents. Environment is number two. That's the same aspect of safety. We want to make sure we're minimizing impacts to non-target species. We don't want to be killing pollinators. And so that's why you're only seeing those spray trucks at night. Bees are not generally very active at night. They're only active during the daytime. So that minimizes those impacts to those non-target species. As well, those trucks are putting out insecticide in droplets that are between 15 and about 30 microns. And just by way of context, the width of a human hair is about 70 microns. So half the size of the width of a human hair. Droplets of insecticide, that's precisely dosed so that it's not going to kill larger bodied insects like bees.
These aren't the spray trucks of the 60s. You're just driving through, kicking a chemical out.
Right. There's not the old foggers anymore. Right. It's called ultra low volume spray technology. Yeah.
That's great. So we also have airplanes, helicopters. You got to have a lot of tools at your disposal.
Right.
To really be efficient.
Yeah, so the idea is that you integrate your approach. You have as many different modes of action. You're attacking the threat, the problem, the risk from as many different vehicles as possible. We also have an education outreach personnel to go, give school presentations and whatnot to help people understand what they can do to minimize their risk of mosquitoes around their house as well. You want to have every tool available so that you can target the control approach to what the problem is. Unmanned aerial vehicles or drones as well, that helps us target sort of niche areas that may be sort of the medium size, that are between a person on hand trying to treat an area, but smaller than needing the aircraft, for instance.
Sure.
But sometimes the problem is so large that you need a vehicle that can cover a lot of acreage. For instance, right after Hurricane Ida, almost 2 years ago now, we had tremendous floodwater mosquitoes that had hatched off. And to really cover the whole area, we had to bring in another contractor and fly our aircraft at the same time to bring that under control.
So when specifically, like helicopters versus airplanes versus drones, what are the specific, times we use each one?
Yeah, it's a great question. And a lot of that we're still trying to figure out. The drone technology is still sort of nascent in what we're doing. So drones we're only using for larval control. We also use that to control water hyacinth specifically, because that is the source of a particular mosquito that attaches itself to the roots of that plant. So we do use the UAV for drone herbicide applications in ponds that are choked with water hyacinth. But the drone is mostly larvicide, and it can get those sort of medium areas. So you really have the vehicle or a human inside of a vehicle treating with a spray wand, then you have the drone, then you have the helicopter, which can treat selective, much larger areas, of course, but not nearly as large as what that plane can treat.
So with water hyacinth, so you guys working kind of synergy with the Public Works Department to clear the water hyacinth as you're spraying? Is there any synergy like that?
Yeah, absolutely. Yeah, so I know the Public Works Department is really focused in on drainage impacts of water hyacinth. If that stuff is choking, culverts and whatnot, they need to get it out of there before the hurricane season. It's not supposed to be there. It's an invasive plant, so impacts to drainage are significant. We're controlling it specifically for mosquito control as the source production. And yes, so we work hand in hand with Public Works to make sure we know which areas they're covering and which areas we're covering.
Okay. We're going to take a quick break, but when we come back, we'll continue talking about the technology and specifically unmanned aerial vehicles.
Great. West Nile virus is a very serious infection in people, but primarily West Nile virus is a disease of birds. Our native bird population is our reservoir hosts for this virus, and mosquitoes are responsible for transmitting it from one bird to another. In particular, it's the bite of the southern house mosquito, which is our primary amplification vector. And that means that mosquito is responsible for most of the amplification of this virus in the environment by biting one infected bird and then subsequently biting another infected bird. Occasionally, other species of mosquitoes will also bite those infected birds, and those species are also very important to transmission because they will then also go and bite people. West Nile virus is our primary focus from March through October every year. And that's because West Nile virus is a very serious disease in people. Though West Nile virus is asymptomatic in most people that are infected by a bite of a mosquito, some of those people will go on to develop West Nile virus fever, which is a summer time of fever where you have headaches and whatnot. You may or may not go see your doctor. Some people progress to more severe neurological symptoms, including encephalitis or an inflammation of the casing around the brain that can occasionally lead to death. About 1 in 150 people will go on to develop these more severe neurological symptoms. But our southern house mosquito, our primary vector, it's being produced in habitats that are rich in organic content. And in particular, these are our roadside ditches that have individual homeowner septic systems that pipe out into those ditches. That extra organic content drives out predators of these mosquitoes, particularly fish. So they have a predator-free environment that has plenty of nutrients, and that is where this mosquito proliferates. Anywhere there's high organic content and water, and this can even include containers in your backyard as well. The development of mosquitoes is closely linked to temperature. So that in the heat of the summer, this mosquito, the southern house mosquito, is going from egg to adult in about 7 days. This means if you have standing water, whether it be in your ditch or in a container, in a flower pot saucer in your backyard, or in a ground pool, if it stays there for more than 7 days, it's likely to have mosquitoes in it. Our job at Mosquito Abatement is to find all these sources and try to treat them all. Of course, over 1,000 square mile parish, there are thousands, hundreds of thousands of habitats that need to be treated once a week, essentially, in this time of year. Our first line of defense against West Nile virus is really understanding where the mosquitoes are, where they're found, and when they're found in high abundances. So we set traps to locate where these mosquitoes are, to look at the population numbers, and also to test these mosquitoes for viruses during the active West Nile virus season. So we set dozens of traps across the parish. We have our biologists out in the field counting mosquitoes that come to land on them. So all of this is in an effort to sensitively locate what areas are producing more mosquitoes across our parish. We bring them back to the lab. We identify these mosquitoes to species, and those that are important species we collect in vials and send off to the lab at the Louisiana Animal Disease Diagnostic in Baton Rouge for virus testing. Every week we're getting that information back and can help us determine where there are problems in just population numbers or also problems in West Nile virus actually in those mosquito populations. Once we know where the problem is for West Nile virus, our first line of defense is trying to kill the larval mosquitoes before they become biting adults. And we do this by using a variety of products that can be sprayed directly into these roadside ditches or containers or any other habitat these mosquitoes are being produced. Our second line of defense is our spray trucks and our spray planes, which are much more visible to the public. So we're here to sensitively detect where the problems are, to send out our trucks and our planes and the larvicide units to control mosquito populations as much as we can. But there's a lot that the resident can do. And the single most important thing a resident can do to minimize their risk for contracting West Nile virus or any other mosquito-transmitted disease is to avoid mosquito bites. That's pretty obvious, but the primary way we do this is through using CDC-approved repellents. And those in particular are those that contain DEET, oil of lemon eucalyptus, or picaridin. And used appropriately with the label directions, these are all effective products as long as they're reapplied at the given frequency on the label to keep mosquitoes at bay. The other things you can do is avoid peak biting times of dusk and dawn, and you can wear long sleeves and long pants to avoid mosquito bites. Beyond that, we're asking residents to help us control mosquitoes more effectively by keeping the vegetation in your roadside ditch cut down as low as possible. That allows our larvicide products to actually reach the water surface to have better control efficacy. Lastly, if you're experiencing a mosquito problem, please notify us so that we can better serve you.
And we are back with Dr. Kevin Caluette, with the Director of Mosquito Abatement for St. Tammany Parish. So we ended the last segment talking about drones, and specifically, that's kind of a newer technology. How long have you guys had drones?
We've had drones probably for about 4 years now. So we were kind of late in the game to adopting drones, trying to let the field figure out how the use is going to be in mosquito control. And there's two ways that we use drones. The first, we have a small drone for really image surveillance exclusively, and we're using that to collect imagery, particularly for our Hyacinth herbicide missions. How effective is that being? But we can also use that image and do some remote sensing to understand where that hyacinth is, understand different targets on the ground as well. The second aspect is a much larger spray drone that can actually treat that water hyacinth, or it can treat a mosquito larvae in the marsh.
You're doing observation and treatment with them.
Yeah, absolutely.
So when we talk about observation, are you using just standard, visual cameras, kind of color spectrum, or?
So far in-house, just the red, green, blue visual sensors. But we also will contract with companies to collect multispectral imagery, to run that other remote sensing. We actually have a contract with a company to collect some LiDAR data across the whole parish, a very high resolution imagery of LiDAR. And so LiDAR will help us essentially create a bare earth model, a digital terrain model it's called. If you stripped away all the vegetation, you could see where all the little basins and buckets might be, that could hold water. And that's really what our goal is. If we do that at high resolution enough, we can see what areas might hold water. But on top of that, we're linking that with real-time sensors in the environment that are recording what's the level of water in the canals, in the rivers and streams, whatnot. And we can feed that real-time data back into the LiDAR digital terrain model to create a real-time, where is the water and where are the little pockets that should be holding water, should have been holding water for a week or more, that could be producing mosquitoes. So if we have that, we can have a predictive map of where we need to go today to try to treat, to larvicide and kill those mosquitoes before they become biting adults.
It's interesting, because we're both on the GIS district for the parish.
Yeah.
We do LiDAR data as well, but we more focus on development, areas where houses are being developed just for flood models and those type of things. So really, you're covering the exact opposite area of what's not developed. Everything we don't.
Space. Exactly.
It's really interesting.
Yeah, that's sort of a near-term project. Hopefully in the next 3 years or so, we'll have operational maps that are predicting where we need to go to do proactive mosquito abatement, because the trucks and the airplanes you see, that's very reactive. That's already after the problem has exploded and there are adult mosquitoes out there.
So your proactive is more your daytime activities.
Exactly. Yeah, if we just need more information about where to target those activities to be more precise and have a larger impact.
So how much has that changed over the last, so you've been there 5 years?
So I've been with Mosquito Abatement for 10 years
10
now.
years, oh, I'm sorry.
Yeah.
Director
is 5 years, exactly. How much has changed over the last 10 years? A lot of that kind of thing we're still working on. So we certainly had a lot of modernization over the last 10 years, but those were sort of more administrative or business operations and clock in and out on your phone, those kind of things. So we're now moving into more data informatics about where the mosquitoes are and how to better attack them. But the future is, what is artificial intelligence going to bring to our field? It might help us understand the environmental triggers and linkages between one mosquito species and rainfall or tide, or all of those things that we still don't really know yet. We need more information about. Artificial intelligence could also improve, newly available insecticides that we can use, or other new technologies that aren't insecticide based to manage mosquitoes as well. So the next 10 years is probably going to have a tremendous amount of change. So it's a pretty exciting time to be in this kind of field.
So I find, right now we're trying to keep as much data as we can exactly for that, because while we may not be doing predictive analysis on every area right now, you want to keep that data so when you're ready to start
you need some training
putting the models in. Yeah, exactly. So I guess same thing for you guys?
Absolutely. Yeah, except that we've always kept the data. All of those traps that we're out there collecting, that data we have all the way back to Katrina. Before Katrina, we were in Slidell proper, and that all the data was lost prior to then, so because we took water in that building. So yeah, we have lots of data from decades now to be analyzed, but to understand those linkages with the environment, we've struggled to find those relationships, and perhaps AI can help us do that in the future.
And where you are now is pretty nice. I mean, you're right next to the Slidell Airport.
Right.
So you have access to the airport with your hangars and everything. You are literally sitting right next to everything you need to have access to.
Exactly. And it's high and dry relative to where we were.
So no flooding issues there?
No flooding issues yet, no.
So you kind of talked about data, and what about quality control? How do you know, are you being effective or are you not? I mean, is that just the traps? What else do you have in place?
That's a great question. And you know, I mentioned the droplet size of those insecticides that we put out. And so I kind of think of the quality control for our office as sort of being both microscopic for those droplets as well as a sort of macroscopic approach. But for the micro side, it is, you know, that we're precisely putting out the right amount of product, number one. The second side of that is we have a whole lab team that is monitoring the resistance, the buildup of resistance in our mosquitoes to make sure that what we're still using is still effective. Because what we're doing essentially is we're creating a bottleneck. We're killing as many mosquitoes as possible, and what happens is one or two of them gets through. They may have a genetic mutation that allows them to metabolize that insecticide somehow. And when that one gets through, it can spread its genes across the population. More will become resistant. So we have to continuously monitor that. And the way they do that, it's very tedious, but it's with a micro syringe, and they're putting a very precise droplet of each insecticide that we use on the thorax, the back of a mosquito, a back of an anesthetized mosquito, right? One by one. They're doing this for hundreds of mosquitoes, and they're doing it for multiple concentrations. And then they look at those concentrations and they see how many are still alive after 24 hours. And if there's lots of them alive, or we see that concentration creeping up that it takes to kill most of those mosquitoes, then we know we have an issue, and we rotate our insecticides so that way we can manage that susceptibility of the population.
It sounds like a lot of work. I mean, hundreds of mosquitoes. I mean, how long does that take?
It takes a good bit, so it's a lot of time investment. But that's the other thing I think that the public really needs to know about what we do is we have such a highly skilled team of scientists, entomologists, lab technicians, and then even the team that goes out in the field every day. These mosquito biologists, they're highly trained, specialized to know what they're doing precisely for this issue, so that we can continue to provide excellent service.
Well, it's nice. I mean, because you basically do all the science to make sure that you keep the environment in good shape while you're keeping the environment in good shape for people with no mosquitoes.
Sure.
As possible.
I think that's the other thing that people don't realize is so mosquitoes touch all of our lives, which is kind of interesting. There's probably no one that you've met that has not been bitten by a mosquito, right? It touches everybody. So a lot of people want us to spray more, want us to spray all the time. And then there's other people that don't want you to spray at all. And so we try to take a balanced approach, a nuanced approach, somewhere in the middle of, okay, well, what is the threat? And when does that threat reach the level that we actually do need to bring control?
Sure.
And so it's a balanced approach. That's what's key in this field in general. And to do that, you need all of those specialists on hand.
Sure.
Yeah.
So where are we going? I mean, we've seen a lot of changes in the 10 years you've been there. Where are we going to go in the next 5 to 10 years?
Well, I mentioned a little bit about the LiDAR projects. I'm hoping that a lot of that will build out predictive models so that, again, we have more proactive control so that we don't have to be spraying these insecticides, out of the truck and the airplane all the time. But, the future, I think, is where AI takes us, and that's something that remains to be seen, where we're going to head with a lot of that stuff.
Sure.
But,
maybe a non-chemical approach at some point?
Yeah, absolutely. And there's a few out there, but none targeted for our particular species of interest.
Sure.
So that's the main issue. Yeah.
So if people want to get in touch with Mosquito Abatement, what kind of services do you provide if people want to call?
Sure. So our website's the best place to go. That's www.stpmad.org. And we have a web form there. If you're experiencing a mosquito problem, we really want to hear about it, because if you're having a problem, your neighbor's probably also having a problem.
Sure.
And we want to bring prompt control as much as possible to those areas. On our website, you'll also see a treatment schedule, so a map of where we're going to treat any given night. You're going to see a treatment history map as well. We have an arbovirus risk map, so where have we detected West Nile virus in the parish, what the current risk level is. It's all on the website there. You can fill out a web form if you want to receive text or email alerts for when we're going to treat. So maybe you're not going to be walking the dog that particular night when our trucks are out there.
That's fantastic.
Yeah, so we can give you advance notice of all that.
That's nice. I think on the website there's a picture of you on a boat.
Yeah, we got to take that one off.
So I appreciate you coming on.
Of course.
It's been great to have you, Dr. Caluette.
Thank you for having me.
And thank you for joining us for Tammany Tech 101. Look forward to you joining us next time.